So the old pump's out, and this happened to be a Lancaster pump. Model T112. This is a 1 horsepower. So it was a Lancaster upper, the pump, and a Franklin electric lower, electric motor, made in USA. 1 horsepower, about 8 or so amps. It's rated. 3-wire, no ground. So these will be hooked directly up to the control box. And what was available to me immediately was a 2-wire pump. So I'll hook that straight to the pressure switch. And I won't have a control box because the 2 major components inside the control box on 2-wire pumps is located inside, I believe, the pump housing. Could be an electric housing too. This is the electric motor down here. Differences between the two. For a 2-wire pump, it's not significantly larger than the 3-wire. Or let's call this a 3-wire, but I still don't know what to call it because it's no ground. Alright. So I was thinking this had been in since '76, but the date code says G90. G90. I called Lancaster this morning, but didn't get a hold of anybody. I didn't want to leave a voicemail about this, but I assume that means July 1990. Let's see, that's a Lancaster pump, and this is a Franklin electric motor. 1 horsepower. It says 8 amps, max amps is 9.6, but normal amps is 8. 0.75 kW, which is like 750 watts. RPM 3450. kVA code is SF 1.4 on this old one. Same as the new. It says Bluffton, Indiana is where it was made. This is made in Mexico, the new one. A few differences I've noticed. The new pump's diameter, if I can find my tool I was using. Well, first we'll start with the pump. Pump housing itself, because that's where my tool is dialed into. No, it wasn't. Okay, we'll just start with the pump. There we go. Old pump's tubular diameter is larger than the new. Old pump's length is shorter than the new. And I would speculate that's because perhaps maybe that's where the relay and the start capacitor is. Old pump's fitting was brass. This is ABS. I've got my check valve over here soaking, but it's also brass. Getting it prepped so I can take it off and reuse it. All the specs on the new pump are almost identical to the old pump. All the specs on the electric motor of the old pump are almost identical to the specs on the new pump. On the new electric motor. Getting us confused here. Franklin electric pump and motor. Lancaster pump, Franklin electric motor. This one has 3450 RPM and 10.4 amps max, whereas this one was 9.6. And normal running amps is about 8.2 amps, and this one is 8.0. So this motor was actually more efficient to a degree, but they're both nameplate stamped as 0.75 kW. Model number 24450890003 Golf. Box says 8 Fox Sierra 1 Papa 4-2 Whiskey 230. 1 horsepower, 2 wire. I don't know what 25A14, what is that, 2025, January 14th manufacture date? We shall see. Made in Mexico. Comes with instructions. Wire differences. The older pump had less conductors in the flex type format. Less conductors, but of a larger circular millimeter. The new pump has more conductors. It'd be helpful if I fan these out. Hang on. Yep, that's what's going to work. Got you on a little bit of a screen blackout right there. I think Miss Britt said she only counted like 7 or 8 of them. Here we go. So here's the old pump. Conductor look-see. Now I don't know what kind of metal this is, but I bet they know not to supply straight copper due to corrosion. I was scraping at it and I couldn't get any copper to show, so I don't know what kind of an alloy that is. The jacket states it's copper. When you read the jacket, somewhere on here it'll say CU 14 AWM or AWG. This will also say copper CU 14 AWG, but you'll see there's many more of smaller. I would rather have this kind of wire on the new pump than I would on the old, because the more hairs of copper you have, even though they're both 14 gauge, the one on the right can carry less current than the one on the left, which is the new pump. A few larger conductors and a bunch of smaller conductors. This is the better choice of wiring scheme, in my opinion. What else do we want to point out? These inlets, the intakes, this is metal, that's plastic. The cover on the electric motor harness going up the pump on the new pump feels like it's plastic. The old one's metal. I'm going to see how much the got chickens complaining outside. Miss Britz, can you hold the camera for me? I need to weigh these. Let's see what the old pump weighs. Remember, the only difference here is we've got, on the old pump, it doesn't have the start relay and the start capacitor. Come on, modern day. Here we go. This says 33.4 pounds for the old pump, and that includes any buildup of debris and any possibility of some water. Now we're going to check the new pump and see what it weighs, to include the 2 rubber bands. It feels lighter. .8 or 28.0, 28 pounds. I'd say the old pump is probably 4 pounds heavier than the new, and the new pump has the start relay and the capacitor inside of it.
Do you need me to hold the camera again while you...
No, that should be good. I got it. Alright guys, let's get busy putting a pump in. Yeah, excuse the dogs. So, what we got here is at about 74 or 5 feet. My water table is at 50 right now. It's pretty dry. Usually I'm right around 30. 25 or 30. The well pump is hitting something. This is a real 6-inch steel casing, and these are the parts that fit on a steel casing back in the day. There's a rubber gasket that goes in between these 2 parts here. On the underside, you have these threaded plates. There's a gasket that goes in between all this garbage, but half of the bottom is missing. This is flanged, the top pieces. Flanged. So that your turn down for your well pipe goes down to your pump. And since this is threaded and we're missing one, there's a rubber gasket that goes in between these 2. As you tighten the bolts, the rubber squishes out and seals around the casing down there. So, I'm in my mid-50s now, but the early mid-20s me didn't know not to take the bolts all the way out because I had trouble with water. I didn't know what I was doing. And this bottom half here fell down the well. I don't know where it's at, but I might be hitting it today, 30 years later. The pump is date coded G90, so that's 35 years ago. I thought it was a 1970s pump. Let's take a look at that rubber gasket I'm talking about. So right here's the pump elbow that comes out. Here's that rubber gasket. Notice it's provisioned equally. And I think I've got these wires ran through the wrong hole. I gotta correct that. Because that's a mounting hole. Mount, 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 mount. Yeah. Got these cleaned up. Got the rust off of this thing, and I hit it with phosphoric acid. That's going to help coat this surface. Keep it stable. Keep the corrosion down on it. But there's my well house down there. So that's what's going on now. I'm going to try to I left the pump pulled off the stop. In other words, it's hanging because I'm thinking the pipe is slightly curved, and if I'm dealing with a offset from the drilling company where they drilled and the hole is kind of cattywampus, where you've basically got two holes that are not lining up correct, but just enough to let the original pump fall, because they may have had to have lifted and dropped back down again. Maybe that's what I'm dealing with. I could be dealing with a rock that became dislodged. But I pulled the pump off the bottom last night with my engine puller, maybe hoping to straighten out the pipe, because the curvature of the pipe might have the pump at a slight angle. So I'm going to bump around a little bit more and see what I can come up with. I don't like the angle that this camera's at, but we've been dealing with it through the whole video anyway. Let me go over there and see what I can find out, see what I can learn. I've got my safety right here. See if I get lucky. Nope, I'm still hitting something. Yeah, I'm still hitting something. I'm right on the bottom right there. So I got to pull this back out again. Put my safety on. There we go. And yesterday with a paracord and a gaff, fishing gaff for muskie, right here. I sent that down in the well. And I'm able to go past the obstruction with this thing, but if I lift off periodically, I'll catch something. So I don't know if I'm catching the bottom of the well casing or if I'm catching the obstruction. But whatever the obstruction is, it's pretty strong. What are my options? I have an old pump that I could tie a rope to with neodymium magnets secured to the bottom of it. And that's what I got going on here. I was trying to drop the magnet down the well, and I just wasn't able to make any progress because it's 6 inches over 70 some feet and the magnet keeps on sticking. to the casing. But I may take this off of the rope. This came out of a computer hard drive. And I may drill the bottom of my cat's on my back. So that's why you see this furry thing. His tail is in the lens. I may take this, drill the bottom of the old pump, and rivet this to the bottom of the old pump. Drop the old pump and see if I can catch that cast iron half moon donut piece of metal and bring it back up. I'll know when I grab because you'll just kind of feel some resistance when I try to. These are extremely strong magnets. What I'll learn is, it's not too much trouble. What I will learn is that the object down there is magnetic. If I hit the obstruction with the old pump and I don't feel resistance when I lift back up because of the magnet disconnecting, then I'll know that it is not magnetic. It's mostly a rock. Primarily, it's probably a rock. So then that is where this cable comes in. I got about 300 foot of cable. I can loop it back with a rebar hook that I got a fabric cobble. It'll basically be shaped like, there's my rebar, and then I'll have a little bit of a hook welded on the side of it. And my hope is, with luck, that I'm able to hook into one of these holes here somehow. One of these holes. Or get lucky and just hook the thing and bring it up. Wow, what a crazy world I'm in right now. My 20s have come back to revisit me. Alrighty, let's keep chooching.